Welcome to a lesson with Dr. Powell. Let's look at an example of integrating um, a line integral with complex numbers. Suppose, for instance, that our function is simply x plus iy. So literally just f of z is equal to z, just to keep things simple. And then we need to multiply it by dz, which is simply dx plus I dy. Okay, so now let's think about the line integral that we want to do it on. Maybe we should, let's do it in two ways. Let's just go from 0 to 1 quite simply on the x-axis. But let's also try going off into the complex plane a little bit, going up there, over, and then down. Maybe just go up 1. Okay, so let's try, let's see, so we're going to have this path up here and this path down here. Now, if both of these paths, if the line integrals are equal on both of them, might give us an idea that there might be some kind of potential function going on that we can use, meaning that maybe there's an antiderivative even of z in complex numbers. Okay, so let's take a look and see how that would look. All right, so if let's just multiply this, let's get our dx. Our dx is just simply x plus iy dx. Okay, so that's the dx part. And then the dy part, we'll just think of these as separate integrals, would be, let's see, a negative y from the I squared, and then plus ix. Just order them so real and imaginary, and then dy. Okay. All right, let's first start off by integrating along this line. Now, this line right here, this path doesn't have, its dr's don't have any dy's, just dx's. So really, we're just going to be using this part right here. Also along this line, y value is 0. So really, the integral right here just amounts to being x dx from 0 to 1 is x squared over 2 from 0 to 1, which is equal to 1/2. Kind of nice. Okay, so basically the integral of even just z from 0 to 1 along here should be that if we take this route. Now, what if we take this other route that goes up and over and down? Let's take a look at that. If we take this line that goes up, this part of the line only has affecting a dy here. So this dr along this path here. So we're just going to be looking at this, and on this line x is 0. So we will just really have for this part, maybe I'll just kind of, so this part right here on the left, we have just it's negative y dy, where y is changing and y is going to be going literally from 0 to 1. And similarly from this, symmetrically, we're going to get a negative 1/2 actually on this left. So we get a negative 1/2 going up here. We get 1/2 going this way. Let's see what happens when we go along the top. Along the top, it's just going to be, this path has no dy's, just dx's. And so we're going to be looking at this part of the integration right here. And let's see, the y value is a constant, 1 along that path, and the x value changes. So we're going to be looking at the integral of x plus I, because I times 1, dx, as we go from, as the x value goes from 0 to 1. So we can compute this, just thinking of I as a constant here, x squared over 2 plus ix, going from 0 to 1. And we end up getting 1/2 plus I. So this top part is just 1/2 plus I. Now, as we go down, let's see what it is on the right side. So on the right side, we have the y value changes and the x value is constant here. The x value is a constant 1, and this path only really has dy's affected here for our dr's as we go along the line. So just looking at this integral here, and we're going down this way. So we're going from y is 1 to 0. So starting at the beginning of the path is 1, and then landing at 0 when we're doing a dy. And our x value is 1. So we just get an I here, and then our y is changing. So negative y plus I dy. Okay, so let's take a look at this. Now, in this particular case, let's see, we can actually, so you see how we have a negative y plus I, and our bounds are from 1, starting at 1, going to 0. If we can reverse the bounds and make that a plus and a minus, if we distributed minus into everything, so that's a minus now. If we change up the bounds, so they're from 0 to 1, then we can compute. This would be y squared over 2 minus iy. As we go from 0 to 1. Now notice what we get here. We end up getting 1/2 minus I. So let's put that in here. 1/2 minus I. Now notice something interesting. When we add up all these parts together, the i's cancel, the negative 1/2 and that cancel, and you end up just getting 1/2 just like we did here. So the line integral along this path and this path are the exact same. So in the next video, we'll keep talking on this point. We might have a potential function kind of happening here. Thanks for watching.